Hi, my name is Oluwaseun Martins, and in this video, we're looking at how to create function in Python. Now, function makes our code reusable. Also, it makes us to use the same code to solve different problems within the same program. So, without wasting time, I'll just switch to my Python in VS Code. Now, to create any function, we need to call the keyword def. So def is the keyword to create function, and what follows after the def is the function call or the name of the function, and after that is the parenthesis. Now in this case the parenthesis is empty. We'll still take on functions whereby the parentheses have arguments, but for now let's just look at the parentheses as it is. And after that you have the colon. Now the keyword def, the function call or the name of the function, then the parenthesis, then the colon. Now in the body of the function here, whatever you have here is what the function will be doing when the function is called. So the first thing to do when you want to create a function is you create function first, then call the function later. So in this case I've created a function using the keyword def, and the function name itself is greet, and the parenthesis here is empty. That means this function is not taking any argument in this case. So I'll just run this. However, the body of this function is that the function will print hello class. That is what this function will print, because in the body of this function you have the print, and you have in a string here you have the hello class. So once I run this, so this function greet has been created, and so the next line here is where I'm actually calling the function. You notice that when I'm calling the function, I'm not calling it alongside the def. The def is just to tell Python that whatever comes after now is a function. So when I'm calling the function, I'm only going to call the name of the function and parentheses in this case. So once I run this, it's going to print, or it's going to execute what you have in the body of that function. In this case, what I have in the body of the function is a print function with the string hello class. So once I run this line now you can see that hello class has been printed. If I try to change this, if I change this to hello Bunny, I run this function again so that function will be updated, then I run this line again, then you can see that has been updated. So you create a function using the keyword def, and what follows after def is the name of that function and the parenthesis, then the colon. After that, the next line is the body of the function. What do you want the function to be doing? You specify that, then you run the line where you have the function. Then at the function call, you only call the name of the function alongside the parenthesis, not with the def like we have done. So looking at function that takes in arguments, here the same function greet in this case, and in the parenthesis here I have an argument called name, and in the body of this function I say print hello in this string, then name, then the next line of the body is print how do you do. So what this function will be doing is that once the function is created, this variable name, which is an argument here, whatever the user puts in into this parenthesis when the function is called will be printed alongside hello here, because the name now becomes an argument which is holding that place, so that whatever the function is called alongside with in this parenthesis as the argument will replace this name, and it will be printed alongside this hello in this first line of the body of the function. So if I run this line, so this function greet that takes in this argument has been created. So here I'm calling the function 3 times. So I call the function here, I say greet in bracket, in the parentheses here I put in bulb in a string, another line of the same function again. I put in the parentheses Shegun, and also I put in the third line in parentheses for the function, I put in wisdom. So if I run this, so you can see Bob has been replaced with name. So hello Bob, how do you do will be printed for this first time the function is called. The next time will be hello Shegun, how do you do, the second time this function is called. And the third time will be hello wisdom, how do you do, repeat for the third time. And that's what we have seen here. So you can see here, hello Bob, how do you do. That's for the first time I ran the function for Bob. Now here is hello Shegun, how do you do. That was when I ran it for Shegun. And the third time is when I ran it for wisdom, hello wisdom, how do you do. So that is how you create a function with arguments. Now you can have as many arguments in a function as you would want. This is just a function that takes just one argument in this case. If you want to have a function that takes in several arguments, you only separate the arguments with commas. So the function knows that, okay, these are the number of arguments I'll be expecting to be called alongside this function. So here we have a function that takes in 2 arguments. And the function is hard underscore numbers. So that's the function name. So def hard underscore numbers, then in parentheses I have x comma y, which means this function is taking in 2 arguments, x and y, and the colon here. So the body of this function has this mathematical expression adding, and adding equals x plus b. So this function is body. The first line of this body is to add these 2 arguments together. Then the next line is to print the sum is, then whatever has been stored in this adding will be printed alongside this string here. So that will be the sum is whatever value that has been stored here will be printed here. So when I run this line, this function hard underscore numbers will be created. So here calling the function here, saying hard underscore numbers in parentheses 4, 6. So it's going to take 4 will take the position of x and 6 will take the position of y. So that is what's going to happen there. Also, you can, okay, let me just comment this out first. Comment this line. So if I run this now you can see that when you add 4 and 6, you get 10. So that's what this first line is doing in the function. So you're going to add the 2 arguments together, which is 4 and 6. And the next line in the body of that function is to print the sum is adding. So that is what we have seen here. The sum is adding because 10 is the value stored in adding and 10 has been printed alongside here. Also, you can first of all specify the value of the arguments in this way. I've said A is 4, B is 6, and I said hard underscore numbers A comma B because I've already defined this identifier B as 6 and identifier A as 4, and I'm saying hard underscore numbers A comma B. So A is 4, B is 6. So I'm going to get the same result. So see, the sum is 10. So that is that about that one. Now we can also have a function whereby the argument has a default value. You know, in that sense, once the function is called, it will print the result of the default value in that function. If you look at this one, I'm calling the same function again. I said def hard underscore numbered, and in this case in parentheses I'm saying x equals 4 comma y equals 6 in parentheses. What I'm saying is that the x argument has a default value of 4 while the y argument has a default value of 6. So whenever this function is called, if I do not put any argument at all in the parentheses, it's going to work with the default value of 4 and 6, and it will execute the body accordingly to get the addition of the 2 arguments x and y. let me do something here. In the case of the previous one where we did hard_numbers, if I do not put any argument in and I run it, you see that it's going to come out with an error because the function is to take in arguments which I have not given. You see now that the third time the function is called, it's pointing it that is an error here, because when I created this function add_numbers, I said this function will take in 2 arguments, but here I didn't supply any arguments. That is why the error is coming out here. And also, if I have specified in this way that okay, by default my argument has default values, if I call the function without any argument, it's still going to work because the function knows that there's a default value for the arguments already created alongside this function. So it's not going to turn out an error like we had in this case, whereby I only created the function with the argument, but the argument does not have any default values. So let me just delete this line. So here we have the function hard_numbered, and here we have 2 arguments, x and y, and x and y already have default value of 4 for x and 6 for y. And the body of the function here is add the 2 arguments of x and y together, then print the outcome of that addition. So I'll just run this function to create it. Now in this case, the first time I'm calling this function, I'm not calling it with any argument. Now we'll see what's going to happen. Okay, let me do this here so that we can see. Let me comment out all of this. So the first time I called the function here, we can see without any argument, I still have the sum of 10. Why that is the case is because here 4 has been taken for x and 6 has been taken for y. So based on that, the function will still operate because the argument there has default values. So it's still going to work even without anything in the parentheses. Let me change this to 6 so that the outcome will be 12, so that we can see that. So see now it's 12 even without any arguments in parentheses, because the function knows that x is having a value of 4 and y is having a value of 6 as the stored value, the default value there. So it's not going to work in that sense. So but here if I uncomment this and I say numbers hard_numbered, in parentheses I'm putting 4. Now what's going to happen in this case, because I created a function to take 2 arguments, x and y, and I've already told the function that okay, x has a default value of 6 and y has a default value of 6 as well. But here I'm calling the function and in parentheses I'm putting 4. What will happen in this case is that the function will take in this 4 in position of x, because x is the first position in the argument, while y is the second position. So it's going to take the value of 4 in this case now for x, saying that okay, x is now 4. It won't use the default value of 6 anymore for x, but it's going to use 4. So it will now be 4 as x and 6 as y. That will be 4 plus 6, that will be 10 in this case. So let me run this. Now we'll see that the first instance is still 12, because at this instance I didn't call any argument alongside the function. So the function used the default value of 6 and 6, which is 12 in addition. But in this case I called it alongside a value of 4. So that takes in 4 for the position of x. So 4 plus 6 will give us 10, which is what has happened here. And like we did earlier, you can also just specify in this case and say okay, my a is 4, my b is storing the value of 6, and let me change this to 20 and call the function alongside the 2 arguments for the identifiers I have named. And we can see that in this case is 26, because 20 and 6 plus 6 will give us 26. So that is how we do that. Now the best way of creating functions is to use the keyword return. Now it's not always appropriate to use the print function inside a function that you have defined. So in place of using a print function to print the output of your function like we have done in this other examples that we have seen, you use the return to actually return the outcome of any function you have created. So just like we have done, the default keyword is def. The function name here is number underscore numbereds, and the argument is taken here is two arguments x and y. And in the body of the function, I have two lines in the body. The first line is result equals x plus y. So the value that will be stored by the user in x and y, or that will be called alongside this function numbers, will be for x and y, and the sum will be done. Now, in place of using the print to show the result of a function, use the keyword return. Now, what is this function returning? It will return this mathematical expression here, which is stored in results. So it will return whatever is stored in this result here. This line will return that. So what's going to happen is that whenever this function is called, the value of results will be returned to where that function is called. So that's what this return keyword does. So it will return this result to wherever this function is called. So let me just run this. So that function has been created. Now I say num1 is 5, num2 is 6, and I'm saying a is storing the value of hard underscore numbers num1 comma num2. So num1 is 5, num2 is 6. So when I run this now, let me comment this print line first. When I run this, what's going to happen is that the outcome of this result, which will be 5 and plus 6, which will be 11, will just be shown. So what's going to happen is that the result will be returned to where this function is called. However, to see that, just put in a and run. So we see here, we see the outcome, which is 11. So we see that what happened is that fine, when we run this line without calling this identifier, nothing was printed. However, this return result has returned the outcome of num1 plus num2, which is 5 plus 6, 11, to where this function is called. However, it was not shown. So to show that, just put in the identifier again and run. So here we see it has returned 11 there, which is appropriate. And also I'm just using this print line. So the print, the sum is comma a. So just add some syntax to we see the sum is 11. Just add some text to my output. Now here's another function that returns absolute value. So I say def absolute underscore value, and it's taking only one argument, num, and in the body of it I have this if else statement. I said if num is greater than or equal to 0. Now we know about absolute numbers. Absolute numbers only returns magnitude of the value and not the sign. So that is what we want to do here. So in this case now, we have if the num is greater than or equal to 0, then return num, which is going to return whatever this num is, because when it's greater than or equal to 0, then it's a positive number. So that's appropriate. It's going to return the num. Else, that means if this is false, then it's going to return this body of else, which is return minus num. So if this is false, that means the num is less than 0. That's what it means. It's less than 0, or it's a negative number once it's less than 0. So based on that, I'll be using minus times that num to return its magnitude, because the sign will not be printed alongside it. So let me just run this. Now I'm calling the function now inside this print function. I said print absolute underscore value, and I'm putting in parentheses 2. And also I'm calling it again. I'm saying print absolute underscore value minus 4. in both cases it's going to return 2 and 4, because in the instance of 2, this if test expression will be true, because 2 is greater than 0. However, in the case of -4, this line will be false. This if condition will be false, because -4 is less than 0. So based on that, the body of the else would be executed, which is minus num. So -4 will give us 4. So as you can see, is 2 and 4 that has been printed. So in this case, I'm trying to create a function that evaluates the area of a triangle. Now we know the area of a triangle requires two things, which is the base and the height of the triangle. So that will be the two arguments that the function will be taking. So def areas underscore triangle, and in parentheses b comma h and colon. Now this is the body of the function. The first thing is to calculate the area of the triangle, which is our base times height, and it is stored in A. So 0.5 times b times h, that's the area of the triangle, and whatever is the outcome is stored in A, and I'm saying return A. So wherever this function is called, whatever is stored in A will return to where that function is called. So let me just run that function. So that function has been created. Now in this case, I'm saying identifier B is storing the value of 3, identifier H is storing the value of 4. So A equals areas underscore triangle B comma H. So what's going to happen here is that the value of 3 and 4 will go in for B and H respectively, and that will come into this first line of the function body to multiply 0.5 by B by H. So, and the value will be stored in A, and the value of A will be returned to where the function is called. So that will be returned here. However, to see the outcome, I'm saying I'm using this print line. Print the area of the triangle is whatever is stored in A here, in this A will be printed here, then mm will be printed alongside it. So we see the area of the triangle is 6.0 mm. So that is what I'm doing. Also, you can take in value from the keyboard into a function. So I'm saying b equals float, input, enter a number, h equals float, enter a number. So let me say here, enter the base, enter the base of your triangle, and here I'm going to say enter the height of your triangle. Let me just copy this, so I will just put only height there. So enter the height of your triangle. So the last line here, we will now do the work, which is print in bracket the area of the triangle is, so the function here is called here areas underscore triangle b comma h. Whatever the user put in for b and h will come here, and that will be evaluated, and the return will return the value of a. Will return this a to where this function is called. It's run the value of that a here and alongside it. So let me just run this. So I'm putting in 3 for b, I'm putting 4 for h. So we see the area of a triangle is 6.0 mm. So what happened was that where this function is called, the return returned this a here. So that's what happened. So that's what your return does for you, and that's the appropriate way by which you create functions. You don't use your print function inside the function, you use the return keyword inside a function. Now here I'm creating a function that would evaluate the average score of a student. So I have here an identifier score, and I have here a list that has 60, 55, 73, 58, 64, 82, 95, 44, and 81 as the data in that list. So here I'm just checking the length of the score of this identifier score. So length equals len, that's the keyword for length of an identifier. So what I want to do is just to count the number of elements here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that will be 9 elements. So if I run this now, we see length is 9, so that's 9 elements in this identifier score. So we know for average you have to add all of this and divide it by the number of it. So that will be the summation of this divided by the length will give me the average of that. So I'm creating the function here. The first function here that I'm creating here is average underscore score, and the argument is taken here is score. So scores equals sum score. So this line will sum all of this score, because that's how you evaluate average. You sum it, then you now divide it by the number of it. So first thing is to sum, then the next thing in the body of the function is to get the total. That's the length of the score. So this one will sum the score, and this one will give me the length of the score. Now average now will now be these scores divided by total, which is what I've done here. So that's the averaged, so which I called averaged. Then I'm using here a print line to say print your average score is. Now this is to format my float, because from the average I'm going to get a float. So I'm saying I only need one decimal place by this colon dot, let me change it to two decimal place. So that will be colon dot 2f. F is float, I is integer, and D is double. So format averaged. Let me undo that. So format whatever is in this average, format it, then return averaged. So it's going to return averaged to where this function is called. Now here I'm creating another function again to check the grade of that averaged. So def calc underscore grade, the argument this one is taking is the averaged. So if averaged is greater than or equal to 70, if this is true, then the grade of the student is A. Elif is greater than or equal to 60, it's a B. Elif is greater than or equal to 50, it's a C. Elif greater than or equal to 45 is a D. Elif equals 40, it's a E. Else the grade is F. So return grade. So here grade is returned. So any of the grade here that is appropriate for the grade of students will be returned, while here averaged will be returned. So let me just run these two functions. So that has been done in just 0.1 seconds. So here I have the score, and here I'm saying creating an identifier here saying average underscore performance equals, so this is where I'm calling the function. This first function I created here, this average underscore score, this is where I'm calling it. I'm calling it alongside this argument score. So that one will give me this average. So return this averaged to this place where the function has been called. And here grade, another identifier, equals calc underscore grade, and the argument this one is now taking here is this average underscore performance, because here the average here would have been returned and stored in this average performance. So calling this average performance alongside the calc underscore grade function will make the grade to use the value here to evaluate the grade of the student. So let me just run this. So we see if you do this and you do the average, you get 66.11. Now that is what has happened here, because I said 2 decimal place I want here. So return average. So because that value has been stored, has been returned here and stored in average underscore performance, then calling that alongside the calc underscore grade makes the grade to function. So print grade, you can see this grade is now printed because the grade that has been returned here has been returned to where this grade has been called, which is stored in grade, and print grade has been executed here and printed as grade is B. Let me just make some few changes so that let me say this is graded, and this will also come to graded, and I run this again and see that it's still working perfectly. So that is for, you can create two functions together in the same line, it should work appropriately. Also here, in place of having two different functions, the first function here is average underscore score, the second one is calc underscore grade. However, they are using the same data. So, but in this case, I want to match the two functions together. So here I have just one function whereby I'm saying def average underscore score, and the argument here is score. So all of this finds the average score of the student, and after that is done, the average is now checked against all of this, and I'm returning averaged. So all the grade which we did in the first place will be the print functions that we have created here in the body of this if, elif, and else control statement. So all the grade that we did initially is what we have used as print function in the body of the if, elif, else that we have created here. This is the initial average calculation, and what we are returning here is the averaged. So that will now be returned to wherever this is called, and in that case, this line of print will be executed, and any of this line of print that is appropriate would be executed. So here now, this is the score I want to use, and at this point is where I'm calling the function. So the average here that is being returned will be returned to this identifier. If I run this, we can see your grade, your average score is 66.1. This is done. This first line is done because of this print function here. So let me change this to 3 decimal place and run this function again so that will be updated, and I run this, we'll see. So you can see here that has been affected. So that's made possible because of this line. And after that, the average is checked against all of these conditions. So whichever is appropriate, whichever body is appropriate will now be printed alongside it, which is what has happened here. That student grade is B because 66.111 is greater than 60, but it's not equal to 70. So based on that, a B is printed for the student. With that, we have come to the end of this class. Thank you.